And in this session, we are going to first take a look like what is AWS Route 53. Second, we are going to take a look like how to set up your hosted zone inside AWS Route 53. Third, we are also going to take a look like how to work with your custom domain and how to integrate with our AWS Route 53. Fourth, we are going to take a look on the name server setting, and also we are going to take a look onto the A record, CNAME record, and aliases. And in the demo section, we will also include like what is simple routing and how to set it up with the AWS Route 53, which will also include like a weighted routing where we will be distributing the traffic based on percentage. Third, we are also going to take a look over there like what is a geolocation-based routing so that we can restrict the traffic based on the request coming from a country. And at last, we are also going to take a look onto the Failover-based routing where we will be setting the primary as well as the secondary routing. Let's first try to understand like what is Route 53 and how it works behind the scene. And for that, I have taken a very basic example, and here onto the screen you can see whenever users tries to enter any website URL. So here you can see it is trying to enter a website which is jhook.org. We will set up this jhook.org domain later into the demo section, but just here I'm trying to explain the workflow. So this user is trying to enter this URL, and as soon as the user enters this URL, this request goes to the domain name system, and which is in this case is our Route 53. So as soon as the request lands on our Route 53, it tries to resolve that particular request based on the name server setting. And once it resolves that request, then that request is forwarded to particular resource which has been configured into our AWS environment. So that request forwarding is happening with the A record. So we configured two things into Route 53, which is a name server records for resolving the domain, and then the A record or a CNAME record for forwarding the request to the particular resource. So here in this example, I'm taking an EC2 instance. But in AWS, you can have a multiple instances or multiple different resources running behind the scenes. So you can serve the same request either with the EC2 instance, or either you can serve it with the Fargate, or you can also serve it with ECS services, or also you can run a Kubernetes cluster behind the scene. So it doesn't matter that in AWS what kind of a resources you are running, but you need to set up the A records or CNAME record properly so that your request will be served back. Before we proceed, I would like to show you the settings which is of our Route 53 hosted zone. So here you can see this is my jhook.org hosted zone which I have created into Route 53, which you can see over here, and these are the settings which I have created for my domain, which is jhook.org. So here you can see there are three types of record. First is A record, there is second one which is name server, which stands NS over here, and third one is SOA. But we are more concerned about the name server record and the A record. So this name server record is responsible for resolving your domain. So whenever a user enters jhook.org, then these name server settings will help is to resolve the request. And these are the name server settings which is given by AWS. And this is the A record which will help us to redirect the request to either EC2 instance, to Fargate service, to Lambda, to API gateway, or any other resources. So this A records we will be creating multiple times during the demo. So this is how our hosted zone look like. Now you're a little bit more knowledgeable about Route 53. So the first thing which we will do is to create our Route 53 hosted zone. And for that, you need to go to the home page of our AWS. And here in the search box, you need to type Route 53 and click on this Route 53 link over here. And here you will find the options to create your hosted zone. So here you can see I have already created a hosted zone, but I can show you like how you can create your own hosted zone for your domain. So click on this hosted zone, and here you will find the option. So here you can see I have already created the jhook.org. Because these settings takes time to come into effect. So that's why I have already created this hosted zone for my domain, but I can show you like how to create your own hosted zone. Let's assume that you have a website which is test XYZ and you need to create a hosted zone for that particular website. So click on create hosted zone over here. In the domain name, type the name and just change the domain name as per your requirement. So here I'm just taking a test XYZ. And after that, you need to select the public hosted zone because we are just trying to point our public domain to this particular Route 53 name server settings. So that's why I'm keeping this as a public hosted zone. And after that, click on create hosted zone. And as soon as you click on it, so it will be ready. And here you will find the details. So this is a name server settings, and these are the name server system settings which is available from AWS Route 3. and these are really important to point your domain. I'll show you like how I have pointed my own domain with these settings. So here are the few details which you need to keep in mind. So this is the first settings which you need to keep in mind, which is a name server setting, and second one is SOS. SOA is not going to use pretty much, but we will be focusing on the name server settings. Now you know like how to create the hosted zone. So let's get back to the original hosted zone which I have created for my domain. So go back to the hosted zone over here, and here click on the jhook.org, which I have already created. And here you will find the settings. So here you will find the first setting, which is the name server setting, which is just similar to the text XYZ which we have created. So these are the name server setting which has been created by AWS, and this is the SOA record which has been created by AWS. But here you will notice a record which I have created for testing purpose, but that's just for a testing purpose. So we will start everything from the scratch. So for that, I'm just gonna delete this record, delete this A record, and yeah, just click on delete. All right, so let's take a look once more. So now the only thing which we have over here is the name server and the SOA record. Now you might be wondering that since I have created this hosted zone for this jhook.org domain, so do I own that particular domain? So the answer is yes, I own this particular domain because I have purchased this domain. So I will show you like how the settings looks like from my domain registrar. So here in the new tab, you can see this is the Google domain from where I have purchased this particular domain. So keep in mind there are two things. First, we need to purchase a domain, and then we need to create a hosted zone for that particular domain in AWS. So the second part which we have already done, so we have already created the hosted zone for that particular domain. And now I'm just going to show you the settings from my domain registrar, because that's the first thing which I have did when I purchased my domain from Google domain. And you can buy the domain from any other service provider like GoDaddy, Namecheap. So there are multiple service providers which are available in the market. So you can just purchase the domain from those services. Alright, so now what are the things which we need to pay careful attention when we need to configure the domains between AWS Route 53 and the custom domain which you have purchased, which in this case is jhook.org. So in the left navigation side, you will find a DNS, which is a really important thing. And I'm also paying a lot of attention on the DNS record, because if you misconfigure these records, then your domain name settings will not work. Okay, so here in each service provider, whether you go with the Google domain, whether you go with the GoDaddy, whether you go with the Namecheap, or whether you go with the SiteGround, everyone will have a DNS settings available when you purchase a domain. So just go and check for the DNS settings when you purchase a domain. So here you can see this is the DNS setting, and I'll show you the default setting which is provided by a Google domain. If you have purchases from a GoDaddy, then they will provide you some default setting. So these are the default name server, and if you go down here, then you will find the name server of my Google domain. So here you can see these are the name servers from a Google domain when I have bought this particular domain, and these are the name server settings which you need to use when you are just trying to host somewhere. But now we are working with the AWS. So AWS provides their own name server setting. So here you can see this is the name server setting, and these are the name server setting for our jhook.org. So there is a little bit of confusion over here, which generally happens whenever you start working with the domain names. So first of all, you need to pay careful attention that you need to point our domain to AWS. So you will be using the name server settings of your AWS, not from the Google domain or a GoDaddy or a Namecheap. So you just need to copy these records from AWS and then go to your Google domain, and here it is showing the default name server of a Google. We don't need to use those. So here you will see a couple of options. So default name server, I don't want to use it. And here you can see your domain isn't using these settings. So I'm not using these settings provided by Google domain, but instead I need to have a custom name server, because I have already created the Route 53 for that. So here you will find a custom name server which is active, and if you go down over here, then you will find the options. So here I have pointed those custom name servers from AWS. So here you will find that NS652 AWS DNS, and you will go and check here, then it is NS652 AWS DNS. So that's why I have pointed that onto the Google domain. Hey, whenever someone is trying to access the jhook.org, then just point that request to this particular name server setting, so that that request is forwarded to this hosted zone settings which is present into my AWS account. I know these settings seems like a little complicated, but let's try to break down the whole logic once again. So here onto the screen, you can see I have created two sections, Google domain on the left hand side and AWS section on the right hand side. And on the right hand side, you will find the hosted zone, which I have created for jhook.org. And as soon as you have created the hosted zone for jhook.org, then you got these name server settings from AWS. You have not created it, AWS has created for you. Alright, so that part is quite okay. But on the left hand side from the Google domain, where we have done the purchase of our Google domain. So we have done the purchase, and as soon as we have done the purchase, then we have got the name servers from Google domain. But since we are working with the AWS Route 53, so we don't need to use the name server settings of Google. So here you can see the googledomains.com. So any records which belongs to the Google domain, we are not going to use those. But instead, we are just going to use the settings from our, or the name server settings from our AWS Route 53. So which is this in this case. And then we are just going to put those custom setting into our Google domain name servers. And here you can see I'm just using these values inside my Google domain, and that I have shown you over here. So if I switch back to my Google domain, and here you will find into the custom name server setting, I'm using the AWS name server setting, so that whenever someone tries to access that particular domain, that request will be routed to the Route 53 hosted zone settings for jhook.org. Let's try to run a very simple demo. Now we have seen like our jhook.org, which has been configured. Now that will point our request to the Route 53, and from Route 53 we will create a record that will point to our EC2 instance. So that's gonna be our first simple demo for this particular concept. And now we need to create our EC2 instance for that. So onto the home page, you will just need to type EC2 over here and click on EC2. And here you can see there are no instances running, so click on launch instance. And here we will first type the name of the EC2 instance. So I'm just going to put test EC2 Route 53 demo. And after that, you just need to choose the machine. So I'm just going to choose Ubuntu over here. And after that, I'm just going to choose the t2.micro. Yeah, I'm just going to stick with the small one. Key pair, I'm just going to select the existing one. You can create your own key pair, but it doesn't matter for this particular demo. And the network setting, I just want to keep everything default over here, but I just need to create a security group also. So here I have already created the SSH, so that I can SSH into my EC2 instance, and also I just need to allow HTTP so that I can access the port 80 of my EC2 instance. And after that, into the advanced details section, I will be inserting the user data script, so that whenever my EC2 instance is booting up, then it will install the Apache by default onto that particular machine. So for that, in the user data section, I'm just going to paste the script. So here it was just going to install the Apache, and then it is at the end, it is going to restart the Apache. And these are the index.html page, which I'm just updating with the host name. So now we are done with the EC2 instance settings. So what I need to do, I just need to click on launch instance. And also one more thing, we need to enable the public IP before launching the instance. So here into network setting, we need to verify one thing, the auto assigned public IP, which is enabled, so that we will get a public IP for our EC2 instance. So click on this launch instance. And I'll be back once this instance is up and running. Here you can see my AWS EC2 instance is up and running. So I need to click on the instance ID to verify my instance in Apache 2 installation. So for that, I'm just going to copy the public IP address, go to the new tab and paste it over here. And here you can see this is showing me the home page of my Apache 2 along with the hostname IP address, and which you can verify from here into the console also. So here you will go and Control F and find, and here you can see the same IP address. So now my EC2 instance is up and running. But the thing is, we are trying to access it with our public IP, but I don't want to access it with my public IP, but instead I want to access this home page with the jhook.org domain. So for that, we need to go to our AWS Route 53 records, hosted zone records, and create a record to point to this particular EC2 instance. Let's go back to our AWS Route 53 settings, and here I'm just going to open one more new tab and click on Route 53. Go to the hosted zone, and here click on jhook.org. And here we need to create a record for our EC2 instance. So click on create record, And here we will first select the simple routing. So just select this one and click on next. And here we need to create a record. So click on define simple record over here. And here, the first thing which you need to pay careful attention is we are pointing our main domain. We are not pointing any subdomain. So we will keep this field empty so that our main domain is pointing to the home page of my EC2 instance. And from the drop down, we need to select a route traffic to an IP4 address. So select this one, and here you need to enter the IP4 address, so which you can copy from our public IP of my EC2 instance. So copy this public address, go to the Route 53 define simple record, pass the IP address over here and click on define simple record. And here you can see our A record has been created. And also we can do one more thing. We can click on edit, and we need to remove this or we need to reduce this seconds, TTL second, because we are just doing it for the test purpose and we just wanted to see the changes in a quick response time. So I'll go over here and I will just change it to 10 seconds so that we can check by accessing the domain. So click on edit records and then select this one and click on create records. And here you can see now we have created our A record, and which is pointing to the IP4 address of my EC2 instance. And here you can check the status also. So click on it and here it is showing pending. So we just need to wait for a couple of minutes and it should be up and running. And here you can see the record is in sync state now. And so we will be able to access our jhook.org domain and it should point to the home page of my Apache 2 instance running into EC2 instance. So here this is my URL. I just need to hit enter. Looks like it has taken a little bit more time to propagate those changes, and here you can see now we are able to access the jhook.org and it is pointing to the IP address of my EC2 instance, which is 172.31.20.21, and which we can verify here also. I would like to refresh this page, and if you go over here, then 172.31.20.21. So that's the IP address now we are able to point with our domain. Alright, so till now we have seen a very basic example of a simple routing. So we have a user which puts a request for jhook.org, which goes to the Google domain, and then from there it finds the name server record for Route 53, and from there it has a record which points to this EC2 instance. This IP address is just an example IP address which might differ when you are going to create your own EC2 instance. But the idea is pretty simple over here when we are using the Route 53. But the problem with the simple routing is that whenever we create a record, so we are putting an static IP address over here. So suppose in another case, like we want to change the EC2 instance and we want to have another IP address, then this record will be unuseful for you, and that routing or the domain will be inaccessible because that resource IP address has been changed and we are using the same IP address inside in our A record. So that's not a best practice to use the A record with a static IP address. To fix this, we need to use the load balancer so that we are hiding our resources under the load balancer and we don't need to provide the static IP address in those cases. So let's take a look on how to set up the load balancer and put the load balancer on top of our EC2 instances so that we don't need to change the IP addresses again and again. So before we jump into our weighted routing, I would like to first tell you about the load balancer and how we are going to configure the load balancer along with our Route 53. So here is a workflow which is quite similar to the one which we have seen previously. So here this is a user which is trying to access the website, which is jhook.org, and it is going to the Google domain, and then from Google domain it is finding the name server record for our Route 53, and then the request is coming to the Route 53 hosted zone. And once that request enters into our hosted zone of our AWS Route 53, then it goes to the load balancer, and the load balancer will then forward that request to our EC2 instances. So here you will see there are a couple of load balancer which we will see eventually into the weighted routing, but the idea is we need to have a load balancer, and then that load balancer will point to the EC2 instance. So that's the ideal way, or that's the more preferred way of using Route 53 along with the load balancer and hiding all the resource behind the load balancer so that you don't need to hard code the IP address of resources for our Route 53. Alright, so now you have an idea like we need to use a load balancer so that we don't need to hard code the IP addresses for our Route 53A record. But now you might be wondering why I'm showing this diagram. So load balancer is one concept which you need to incorporate when you're working with the Route 53. But on top of that, you also need to set up your proper networking, which means you need to set up your AWS account, which I'm assuming that you already have an AWS account since we are working inside our AWS cloud. Second, the important thing is you need to work inside a VPC. Although there is a default VPC available by AWS whenever you get or whenever you sign up for AWS, but we are not going to use those default VPC. We are going to create our own VPC, and inside that VPC we are going to create a public subnet as well as the private subnet. And after creating those public and private subnet, we are just going to create an internet gateway for our public subnet so that public subnet can access the internet. And after that, we are just going to create a route table, and these route table will be responsible for forwarding the request to our public subnet as well as to our private subnet. And once we configure the route table, then we are just going to provision the EC2 instance inside my public subnet as well as my private subnet. So this is the minimal network setting you should do whenever you are working with our Route 53 and the load balancer, because these are the more ideal practices which you need to follow whenever you're trying to set up this kind of a environment. So what we will do now, we will just set up these things like a VPC, public subnet, private subnet, internet gateway, route table, and EC2 instance. Once we set up all these, then we are going to provision the load balancer, and then we are going to point that load balancer to our Route 53. Alright, so let's take a look like what resource we need to create first. So we already have a AWS account because we are already working inside our AWS account. The next resource which we need to create is the VPC. So switch back to your console onto AWS. So here is my AWS console. Go to home page. Here in the search box, type VPC, click on VPC. And don't worry, we are going to take a look onto the weighted routing, geolocation-based routing, and the failover routing also once we set up all this networking. So here, first thing we are going to create is the VPC. So click on create VPC, and here click VPC only and type the name. So here I'm just going to put test VPC, the IP CIDR range. So here I'm just going to put 12.0.0.0/16. So that's the IP range for my VPC. Tenancy, I'm just gonna put it to default, and tags, I'm just gonna keep it everything default. Then click on create VPC. And here, just go to your VPC, and here you can see our test VPC has been created. Now, after creating the VPC, the next resource which we need to create is the public subnet as well as the private subnet. So let's go back to our AWS home console, and here into the VPC dashboard. Here you will find the options for creating the subnet. So click on subnets over here and click on create subnet. So first of all, we are just gonna create a public subnet, and that subnet is present inside my VPC. So this is the VPC, and the name of the VPC which we have just created is the test VPC. So here the first option you will find is to select the VPC. So here you will find a test VPC which we have just created. And here we are just going to create the subnet. So here, first of all, I'm just going to create a test public subnet, and subnets are just for the availability. Suppose if you are having a multiple subnet, then those subnets are present into the different region. So if something goes wrong with the one data center, then you will have another subnet present into another region available to serve those requests so that you get a maximum availability for your resources. So here I'm just creating a first public subnet. So I'm just gonna put 1 and 1A over here. And here in the availability zone, I'm just going to choose Europe Central 1A. So that's why I have suffixed it with the 1A so that I can identify in which availability zone I'm creating this particular subnet. Alright, so that's it. I have selected the Europe Central 1A region, and here we need to enter the IP range for our public subnet. So this is the IP range or the CIDR block from the VPC. But here I'm just going to enter 12.0/1/0/24. So here I will have a 256 IP available inside my subnet. So that's the IP address I'm just going to use for my public subnet. I'm just going to copy the name because we are just going to create one more public subnet for maximum availability. So that's a one subnet. I'm just going to click on add one more subnet. I'm just going to paste it over here, and here I'm just going to put 1B. And here availability zone, I'm just going to select Europe Central 1B. The IP range I'm just gonna keep 12.0 dot let's put 2.0/24. Here you will see that I am using the different IP range for different subnets. So here in the first subnet I'm using 1.0 and here I'm using 2.0. Alright, so now we have created two public subnets. So let's create a one private subnet as well. So click on add new subnet and here just enter the name and I'm just gonna modify it to make it a private, and I'll put 1 and 1A for Europe Central 1A. So here select the Europe Central 1A, which is the availability zone, and the IP range I'm just gonna put 12.0.3.0/24 so that I will have a 256 IP addresses within my private subnet as well. Alright, so I have created the three subnets. One is private and the two public subnet. So after that we are just gonna click on create subnet. So click on create subnet over here. And here you can see our subnets has been created. So if I scroll it down, I'll just remove those filters so that it's easy to view over here. I'll just close this one. So here you can see our subnets are visible over here. So there are some default subnet which you can see over here. There are no names associated with it. If I can zoom out, so it might be visible. Yeah. So here you can see our three subnet has been created. So let's go back to our diagram and see what resource which we need to create next. So here we have created the VPC, we have created a public subnet as well as private subnet. So the next resource which we need to create is the internet gateway. So for that, again, go back to the home page, go to the VPC dashboard and click on internet gateway. From the left navigation menu, click on internet gateway, and here I'm just gonna put the name. So I'm just gonna put test IGW. IGW is just an abbreviation for an internet gateway I'm using, and just click on create internet gateway. And here you can see our internet gateway has been created. So click on internet gateways, and here you will find the test IGW. But here you will notice it is detached. It has not attached with any VPC. So what we need to do, we just need to click on internet gateway. And here you just need to go to action, click on attach VPC, and here you need to select the VPC, which is our test VPC, and then click on attach internet gateway. Why we are attaching this internet gateway? Because if you take a look onto the diagram, then this internet gateway is sitting inside the VPC. So that's why we need to attach it to that particular VPC where we are working. So now we have created our internet gateway as well. Since we have created the internet gateway, the next resource which we need to create is the route table. So here, this is the route table which we will be using for our public subnet as well as for our private subnet. So let's go back to our console over here, and here onto the VPC dashboard. In the left navigation menu, you will find the route tables, and also in the home page of the dashboard, you will also find a route table. So click on any of the options. So here you will find some default route table, but we are not going to use those ones. So we are just going to create a new route table. So first, let's create a route table for our public subnet. So I'm just going to put RT test, and then I'm gonna put RT for route table, and then I'm just gonna put public so that it belongs to my public subnet. And here again, everything we are doing inside the VPC. So I'm just gonna select the test VPC over here, and then I'm just gonna click on create route table. So here you can see our test route table public has been created. I'm just gonna create a one more route table which is private. So I'm just gonna click on create route table, put test RT, and here I'm just gonna put private and select the VPC. So I'm just gonna choose test VPC again, click on create route table. Alright, so now we have created both the route tables. So let's verify those. And here you can see our test public and test private route table has been created. But if you take a look onto this diagram, so here in the public subnet, we need to have a route table which we have just created, but this route table needs to have an internet gateway also. And also it should attached with our public subnet, because this route table, although there are two route table, but here in the diagram, I could not show both the table because of limited space. So just I have shown one single route table over here, but just assume that this is our public route table. So what we need to do inside this public route table is to attach the public subnet as well as let us know the internet gateway inside the route table so that this public subnet can access the internet. So that's the importance of our route table. So let's go back to our route table over here, click on this public route table, go to actions, and here first click on subnet association, which is this one. So click on edit subnets, and here we need to choose only the public subnet because this is our public route table. So I'm just going to choose these two subnet which we have created. Click on save association, and here you will verify that the subnet association, here we have added a public subnets inside my subnet association. So this particular route table RT public has been associated with our public subnet. All right, that's been done. The next thing which we need to select is the route for an internet gateway. So if you take a look onto this diagram, so this route table has been associated with subnet, public subnet, but we have not associated with our internet gateway. So let's go back and here click on edit routes, and here click on add routes, and here you need to enter this address 0.0.0.0, which means this public subnet can access the internet from, or the internet can access this public subnet from anywhere. So this is a two-way communication happening. So if I am sitting from anywhere in the world, so I should be able to access this subnet inside the VPC. So that's the route we are just trying to create. So use this IP address, select the internet gateway over here. So internet gateway, which is this one, and this is the test internet gateway which we have just created. So just use this internet gateway and then click on save changes. And here you can see our public route table is ready, and now we have an internet gateway for providing an internet access for our public subnet which we have just associated. All right, so that's been done. Let's go back to route table once again, and now we will work on our private route table. So click on this private route table ID, go to subnet association, click on edit subnet association, and here we will be attaching only the private subnet, not the public one. So click on save association, and here you can see our private subnet has been associated. And the routes, we are not going to create an internet gateway over here. Otherwise, it will defy the purpose of our private subnet. Private subnet doesn't have an internet access, and no one from any part of the world can access the private subnet. So that's why we call it as a private. So that's why I'm not assigning any internet gateway over here. All right, so let's go back to our diagram once again. So here you can see our route table has also been created now. Let's move ahead, and the next resource which we need to create is the EC2 instance, and then we are going to create an EC2 instance inside our public subnet. So let's go back to our AWS console over here, go to home page, and here click on EC2 instance. And here you can see our one instance is already running, but that is just a default instance which I have created, which is running without any, which is running inside the default subnet, default subnet and the default VPC. So what I'll do, I'll just terminate this instance because we don't need it at this moment. So I'm just going to terminate this instance over here, and I'm just going to create a new EC2 instance inside our VPC and inside our public subnet. So here, if you take a look onto this diagram, then I'm talking about this EC2 instance inside this VPC and this public subnet. So let's go back to our browser over here, go to EC2 dashboard, and I'll refresh this one. So here you can see that instance has been terminated. So now click on launch instance. And here I'm just gonna choose like a test EC2 instance, and here I'm just gonna choose Ubuntu as my base image, and here instance type t2.micro, I'm just gonna choose that one. The key pair, I have already created this key pair, but if you want to create a new key pair, then you can just click on create new key pair, and that will let you create a new public and private key for our EC2 instance. All right, so that's been done. Click on network setting. We need to edit this network setting now. So here we will first choose the test VPC because we are working inside the test VPC. Then subnet. So here I'm just going to choose the first subnet, which is public, this one. Auto assign public IP. So I'm just going to enable that one. Then security group. So here I have already enabled the SSH for our EC2 instance. So I'm just going to enable one more security group, and here I'm just going to put HTTP over here, port 80, and it should be accessible from anywhere so that I can access the default page, which I'm just going to install Apache for that. So it should be accessible on a port 80. So that's why I'm just going to enable these two security groups. All right. that's been done, and I'm just gonna go with the default storage. That's fine. Go to advanced detail, and here I'm just gonna use the user data section. If you go down over here, then you will find a user data section. So from a notepad, I'm just gonna copy one script which I'm just gonna show to you. So this is the script which I'm just gonna pasting over here. So this is a user data script which is going to install this Apache, as well as it is going to update the index.html page, which we will be accessing later, and which you have already seen into the first demo where I have shown the home page. So here, this is the default page where it will be showing you the host name and the IP address. And after it is installed, then it is going to restart the Apache, and everything will happen on the boot time of our EC2 instance. All right, so let's click on launch instance over here. And it will take a couple of minutes for this instance to come up and running. So I'll be back once this instance is up and running. Alright, so I have refreshed this home page of my EC2 dashboard, and here you can see one instance is running. So I'm just going to click on it. So here you can see this is the test EC2 instance which we have just created inside our public subnet. So click on this instance ID, and here you can see the public IP address. So just copy this IP address to verify the Apache 2 home page. So just hit enter, and here you can see our EC2 instance is running, and now we can access the Apache 2 home page, which is this is the private IP address of that instance, which you can verify from here also. So here you can see this is the IP address of my Apache 2, EC2 instance running the Apache. All right, so now we have seen the EC2 instance has been up and running. So the next thing is now we need to configure the load balancer for this EC2 instance so that we don't need to access using this public IP address. All right, so to do that, what we need to do, we just need to create a target group. So target group you can create from the left navigation menu from our EC2 dashboard. So if you go to the load balancing section, so here you will find a target group. So click on this target group, and here we need to create a target group. So target group is the logical grouping of our EC2 instances so that our load balancer can choose this particular group to forward the request. So that's the meaning of our target group. So here I'm just going to select the instances. After that, I just need to put the name. So I'm just going to put test TG for target group EC2. And here I'm just going to select the port HTTP, IP4, but here you need to select the correct VPC where you are working. So I'm working into the test VPC. So select that one, move ahead, and then click on next. And here you can see this test EC2 instance is already showing over here when I'm just about to create the target group. So here just select that one, include as a pending below, because this target group can have a multiple number of EC2 instance. Although I have created only one EC2 instance, but you can have more than one EC2 instances inside the target group. So just select that target EC2 instance inside the target group and click on include as pending below. So here we have included that one, and then click on create target group. So now our target group is ready, and this target group contains our one EC2 instance, which you can see over here. All right, so now we have created the target group. The next thing which we need to create is the load balancer, and I'm just going to show you like how you can access the load balancer URL to access the EC2 instance. Okay, so again, go to the left navigation menu, click on the load balancer, and here we are just going to click on create load balancer. So click on create load balancer, and here we are just going to choose the application load balancer. So click on create. So here I'm just going to create an application load balancer. So here we need to enter the name. So I'm just going to put test LB for EC2. Okay, so this is going to be the load balancer for my EC2 instances. All right, so here I'm just going to keep everything default. Internet facing, yes, I want internet facing. IP4, yes, I want IP4. Here we need to choose the VPC. So I'm just going to choose the test VPC where I'm working right now. And then we need to select the availability zone of our public subnet. So I'm just going to select Europe Central 1A. And here you will see the public subnet 1A. And then I'm just going to choose another one, which is 1B for my public subnet. All right, so those has been selected. Security group, this is important because security group is necessary for your load balancer. So the first security group we will enable is for port 22 so that we can SSH into our EC2 instance, and then we are just gonna enable the port 80 also so that we can able to access the Apache 2 homepage. Otherwise our load balancer will not allow to access the Apache homepage. So for that, click on create security group, and here I'm just gonna put the name, so test security group for load balancer. So this is a test security group I'm creating for a load balancer. So here I'll put a description like allow SSH and port 80. Then select the VPC. So I'm working on a test VPC. So select that one, click on add inbound rule, select SSH over here and put anywhere. So anyone can from anywhere in the world should be able to SSH into our EC2 instance. Add one more rule and here put HTTP. This one, and select anywhere from the world. So anyone from anywhere should be able to access the home page of my EC2 instance. All right, so that has been done. So click on create security group. And here you can see our test security group has been created. So just copy this name, which we need it. And again, go back to our load balancer. So here we are just trying to add that security group. So from the drop down, just refresh this page. And here you will find the test security group which we have just created. So select this one, and here the next thing is listeners and routing. So here we need to configure our target group which we have just created previously. So in the drop down you will find a test target group, and inside that test target group we have already included our EC2 instance, so that's already there. So now our EC2 instance has been added as a target group inside the load balancer. Then move ahead and verify the details. So here are the basic details for my load balancer, which includes the security group, network mapping, and the listeners. All right, so that's been done. Then click on the create load balancer. And here you can see the load balancer has been created, but it will take a couple of minutes to provision. So if you go over here, so here you can see the state is provisioning. So I'll be back once this load balancer is up and running. So I'll refresh this page after a couple of minutes, and here you can see my load balancer is now active. So click on this load balancer over here and copy this DNS name and go to this new tab over here and hit enter. And here you can see it is now pointing to the EC2 instance, and we are not using any public IP of my EC2 instance anymore. We can just simply access it with our URL of our load balancer. Sorry to pause you in between of this particular session, but I would like to encourage you guys to please subscribe to this channel, because I have seen like many of you watch and enjoyed this kind of a session, but you don't consider subscribing to this channel. Being an open source community member, I also spend some time on creating and drafting these sessions, which takes quite a significant amount of our time. So do me a favor, please consider subscribing to this channel, which will really help me and keep boosting, putting my effort to create similar content in future as well. So let's continue with the session. Now we have created the load balancer. So let's take a look onto the diagram once again. And now we need to fix the linking between the Route 53 and the load balancer. So I'm talking about this Route 53 and the load balancer. We have already fixed the linking between the load balancer and the EC2. So we are able to access the EC2 instance from our load balancer. But we need to create a record so that our Route 53 can redirect the request to our load balancer, and then the load balancer will forward that request to the EC2 instance. So let's go back to our AWS console and go to our Route 53. So I will just close all these windows over here. I'll close this one and go to my home page, and here in the search box type 53, that will point to the Route 53. Go to the hosted zone over here. Click on jhook.org where we are working, and here first of all just remove this entry because we are no longer using the static IP address. We have already seen that. So I'm just going to delete this record. Click on delete, and now we are just back with our hosted zone when we have created for the first time, which has a name server and SOA record. So now we need to create a new record for our load balancer. So click on create record. And here we are again going to choose the simple routing. Click on next, click on define simple record, and here we are gonna point our main domain to our load balancer. So select the main domain, which is jhook.org, And here we are just gonna select the A record because we are just gonna use the A record once again. And here the choose endpoint. So instead, previously we have specified the IP address over here, which is like a 192.xxxx something. But we are not gonna use that IP address anymore. We are just gonna use the load balancer over here. So from the top down, you just need to select the load balancer. So here you will find the alias to application and classic load balancer. So select that one. And as soon as you select the application load balancer, then it will ask like in which region those load balancers are present. So here we need to choose the correct region. So in that case, our region is Europe, Frankfurt, Central 1A. So this is the region where I'm working. So as soon as you select the region, then it is going to ask like for which load balancer you want to choose. So here you will find the load balancer which we have just created, which is test LB for EC2. So select this load balancer and then click on define simple record. So click on it, and here you can see our A record has been created, and now it is pointing to our load balancer instead of IP address. So click on create records, and here you can see our record has been created. So now what we will do, it will take a couple of minutes to activate this DNS propagation, and it might take more than 2 minutes as well. So just be patient. Sometime I have seen that it takes around 5 to 15 minutes as well. So but here I'm just gonna first of all click on view status to verify this. So still you can see the status is pending. So I'll be back once this propagation has been in sync. Alright, so now the changes are in sync, and here you can see the green icon. So I'll go back to jhook.org homepage of my hosted zone, and here we can verify the details once again. So here we are having a record with the load balancer. So now I will open a new tab over here. So I'll close this one, and here I'm just gonna type jhook.org, and it should point me to the EC2 instance. And here you can see this is the IP address which I'm getting, which is of my EC2 instance, so that we can verify that I'm just getting redirected to the correct EC2 instance or not. So the IP address is 12.0.1.47. So go to EC2 and go to dashboard over here and refresh this once again. Click on this instances, and here you can see this is the instance which is running. Click on it, and here you can see the IP address. I'm just going to zoom in a bit. 12.0.1.47. So it is redirecting to the correct EC2 instance, and we can verify the network details as well. So here you will find the VPC. Here you can see this is our test VPC and this is our subnet. So it is pointing to the correct EC2 instance. So now you can see that instead of using the hard-coded IP address, now we are using the load balancer, and it doesn't matter how many EC2 instances you are running behind the load balancer. You can point n number of EC2 instances, and you don't need to change this record anymore. And this will point to all the resources present inside that particular load balancer target group. Alright, so now I'm assuming that now you're a bit more familiar with the Route 53, and now you know like how to work with the A records and how to set up your load balancer so that the Route 53 can redirect that request to our load balancer, and then eventually you will be able to access your EC2 instance. Now we will talk about the weighted routing. So as the name suggests, the weighted routing, which means we will be putting a percentage to share the traffic load onto multiple load balancers. So here you can see onto the screen, so we have already seen like how to configure a one load balancer, but in this example we are going to configure multiple load balancer. So our Route 53 will have a multiple load balancer, and then it will redirect those requests to the EC2 instances. So here you can see the first load balancer will forward that request to first EC2 instance, and the another load balancer will forward that request to another EC2 instance. And also we can configure the percentage, like how much traffic of percentage should be redirected to the first load balancer and how much it should be redirected to the second load balancer. So that's what we call it as a weighted routing. So let's jump to our AWS console and start setting up the another load balancer. But before I set up another load balancer, I need to set up another VPC. So I'm just taking the same diagram once again, and I'm not gonna repeat the same process once again because it will be boring for you. So as you remember, we have already created a test VPC, which I can show you. So here onto the dashboard, you can see, go to the VPC, and here you will find the option for a VPC. and here you will find the test VPC. So this is the test VPC which we have already created, but I'm just gonna create a one more test VPC 2 so that we can create another load balancer inside the VPC. So I'm just talking about this one. So I'm just going to create a one more load balancer so that it can present inside another VPC. So this is our first load balancer, and this is going to be our another load balancer into the test VPC 2. So just follow all the steps which I have shown previously while I am creating the test VPC. So I'm just going to use the exact same steps. But the only thing which I'm just going to change over here is the IP range. So since I'm already using the 12.0.0 for my test VPC, which I can show you here. So this is the IP range which I'm using for a test VPC. So instead of that, I will be using 13.0.0 for my test VPC 2. So I'm just going to create the whole test VPC, subnet, route table, internet gateway, and then I'm just going to be back, and then we will be creating EC2 instance and load balancer, and then eventually the Route 53. Alright, so moving ahead, so here you can see onto the screen, so I have created the test VPC already, and here I have created the test VPC 2 also. Now the next thing is we need to create an EC2 instance inside our test VPC 2. So what I'll do, I'll just go to home page and click on EC2 instances, click on create or launch instances. Here I'm just going to put the name, so I'm just going to put test EC2. I'm just going to put VPC 2 as an abbreviation to identify the EC2 instance. Then put Ubuntu as my base operating system, and then I'm just going to choose t2.micro. That's correct. And I'm just going to choose the same key pair. You can create your own key pair also, that's fine. Click on edit network setting. Here I'm just going to choose the test VPC 2 now. So here, based on that, I will choose the subnet. I only created the public subnet. So here you can see the test subnet 2 and test subnet 21A. I have not put the public keyword here, but these subnets are public subnet, just so that you keep in mind. All right, so I'm just going to select 1A over here, auto assign public IP enable, and then here I'm just going to create a security group. So SSH is already there. I'm just going to add one more. So here I'm just going to choose HTTP and choose it from anywhere, source type from anywhere. That's done. And storage 8 gigs, that's fine. Into advanced detail, I'm just going to install the user data section. Here I'm just going to copy the script for installing the Apache, copy and paste it over here. So here you can see the Apache installation script. And after that, I'm just going to click on launch instances. And here you can see our instance has been launched. So go back over here, and here you can see it is in pending state. So I'll be back once this instance is up and running. And here you can see our EC2 instance is up and running. So click on this instance ID, copy this IP address, go to the new tab and hit enter. And here you can see the home page of my Apache 2, and the IP range is 13.0.1.25, which belongs to my test VPC 2 and the public subnet. Alright, so now my EC2 instance is up and running. So if you take a look onto the diagram once again, so here this EC2 instance is running. I'm talking about the below one. So here I need to configure the load balancer for the test VPC 2 EC2 instance. So go back to your home page of my AWS dashboard, click on home page over here, and here go to EC2. In the left navigation menu, we need to create a target group again. And here this was a target group for my test VPC, but here I'm just going to create another target group, and here I'm just going to put test target group for test VPC 2 so that I can identify which target group belongs to which VPC. All right, port type is HTTP, that's fine. Here I'm just going to choose the VPC, that is test VPC 2, and after that HTTP, that's fine, attribute, then click on next. Here you will find the instance which we have just created. So select that one, include as a pending resource, and here we have added it. Click on create target group. And here you can see our target group has been created. And the next thing which we will do over here is to create a load balancer. So click on load balancer from the left navigation menu and click on create load balancer. Choose application load balancer, click on create. Here I'm just going to put test LB for EC2 test VPC 2. Okay, so this is the load balancer for my test VPC2 EC2 instance. Here I just need to choose the test VPC. So here I will choose test VPC2, choose both the subnet, public subnet. Then security group, let's check if we have that security group available or not. So I don't think that security group is available, which we have created for a previous load balancer. So I'm just gonna go over here, and here I'm just gonna create a security group. So I'm just gonna put test security group for LB, and I'm just gonna put test VPC 2, and here I'm just gonna put allow SSH and port 80. Select the VPC, so I'm just gonna choose test VPC 2, add rules. First of all, allow SSH, custom, it should be from anywhere. Add one more rule, put HTTP over here and choose anywhere, and then yeah, we are good to go. Click on create security group over here, and here you can see our security group has been created. Copy the name, go to load balancer, refresh the page, and here select the security group over here, and now we have added that security group into load balancer. And go ahead, and here we need to select the target group where we have already included our EC2 instance. So just select the drop down, and here you will find the target group from our test VPC2. Select that one, go ahead, and here you will find all the details about your load balancer, and then just click verify those details, and then click on create load balancer. And here you can see our load balancer has been created. Let's verify the status. So here you can see it is in provisioning state. So I'll be back once this load balancer is up and running. After a couple of minutes, my load balancer for test VPC2 is up and running. So click on this load balancer and go to DNS name, copy this one and go to new tab and hit enter. And here you can see the IP address of my VPC or EC2 instance from my test VPC2, which you can see over here. So this is the IP address which is starting from a 13. So now my load balancer is up and running. So let's take a look onto the diagram once again and try to understand where we are. So now our setup is ready, but we need to create a records inside my Route 53 so that we can divide the traffic 50-50% between these load balancer, and also we'll try to tweak that parameter. So instead of sending 50-50, we will try to change it to make it like a 90-10 or 80-20. So let's go back to our AWS homepage and try to configure these records inside our Route 53. So here is my AWS. Go to homepage. I'll close all the tabs over here. Go to Route 53. Click on hosted zone. Go to jhook.org, and here first of all delete this record because that we don't need it. That is a simple routing. Here you can see this is a simple routing, but we need a vetted routing. So I'll just close this one. I'll just delete this record. Click on delete, and then we are just gonna create a new record. So click on it. Here you need to choose the correct option. So here I'm just gonna choose the vetted routing for this one. So select vetted routing. Click on next. And here I'm just gonna go with the main domain. I'm just not gonna use any other domain. So here I will choose the A records because yes, we want to create a record. And here we need to define the weighted record. So here click on weighted record, and here we need to choose the endpoint. So first of all, we are just gonna select the first load balancer. So here select the type of a endpoint. So that is going to be our application load balancer. Select the region. So I'm just gonna choose Europe, Frankfurt, and here you will find the option for a load balancer. So here you will find two options. So we are just gonna go with our first load balancer, which is test LB, and then just before creating this test record, we need to define the weight. So weight is like where we'll go with the 50-50% first of all. So let's choose the 50%. So here you need to enter the value between 0 to 255 because it's like a 256 bits. That's why you need to enter the values. So I will put around 128 because or 128 or 127. So let's go with the 128 because that's the 50% of our 256. So that's the key thing which you need to keep in mind. So I'll just put 128 over here. Health check, I'll just skip it. And the record ID. So I'm just gonna put a record for test LB. So that's the identifier. click on weighted route. So here you can see the first record. I'm just going to add one more record. Here I'm just going to choose the endpoint to be the application load balancer. Here I'm just going to put 128 over here also, and here I will just put the ID. So I'll put a record for test load balancer 2, which includes our test VPC 2. Put a dash over here also, and then click on define weighted routes. We need to choose the region also, I forgot. So here I will choose Europe Frankfurt, and here we need to choose the load balancer. So I'm just going to choose test VPC 2 load balancer, and I think we are good to go. Click on create weighted routes, select all of it, click on create records. And here you can see there are a couple of records now. So here you can see first record with 128 and another record with a 128, which means our traffic will be split at 50-50% between these two load balancer, which you can see over here. This is from test VPC2 load balancer, and this is the first load balancer which we have just created. So wait for a couple of minutes, just check the status over here also. So it's in pending state, so it might take a couple of minutes or more. So I'll be back once this is up and ready. Here you can see it is in sync now. Alright, so let's do one thing. Let's try to verify by accessing the domain. So I'm just going to go and type jhook.org over here and see where our request goes. So here you can see our request is going to 13.0/125. So that's our EC2 instance running into test VPC2. So if I refresh it, so still it is going to that particular EC2 instance. So what we will do, we'll just try to reduce the percentage of our EC2 instance running into test VPC2 so that our request goes to the another instance. So for that, what you need to do, you just need to go to the records, go to hosted zone into our Route 53, and here into the records, you just need to identify that particular record first. So here you can see this is the test VPC2 instance or the load balancer record. So what I'll do, I'll just select this one, click on edit record, and here instead of 128, I'll just mention like, let's say put 1 over here, or maybe we can put it 0, and then click on save. And I'll just verify the status later, and also I'll just update this record as well. So click on edit record, and here you will put 255 so that all the requests goes to the another EC2 instance. Click on save over here. All right, so let's check the status over here. It's in pending state, so I'll be back once this status has been changed. And also why I did 0 and 255, because I'm just running everything into a limited environment. I don't have multiple number of requests, like thousands of requests coming to EC2 instance. So those split cannot be so visible significant if we go with the 50-50. That's why I have just gone with the 0 and 100%, so that you will see the difference quite immediately. So that's the reason behind splitting the traffic. Instead of 50-50, I'm just going with a 0 and 100%. All right, so here you can see it's in sync now. So let's try to access the jhook.org, and now it should go forward all the requests to the another first test VPC, which starts with our 12.0 IP range. So I'm just gonna put that one, and here you can see it's forwarding all the requests to my old VPC, which is a test VPC, and which you can verify from here also. Go to EC2 instances running, and here this is the old instance which is starting from a 12. So this is how the weighted routing works, which you can split the traffic between the different load balancer. If you are using the load balancer, you just need to define the weighted percentage in terms of 0 to 256. So just choose suitable number and divide the traffic between those two load balancers. Moving forward, the next routing which we will talk about is the geolocation-based routing. So here all the setup is still the same. We are still using the same load balancer, same EC2 instances, but we are just going to modify our A records. Instead of weighted A records, now we will be creating a geolocation-based A records. So here we will try to configure a first load balancer for Sweden and another load balancer for Finland. And I'm just going to use the VPN to test this particular feature. So let's go back to our AWS Route 53, delete the old weighted records and create a new geolocation based records for routing. So I'll go back to my browser, I'll close this window and I'll close this one also. Go to hosted zone, go to jhook.org, and here first of all delete this weighted records from the Route 53. Select both of it, click on delete record and click on delete. Alright, so now I have deleted both the records and our jhook.org will not work anymore. So if I open this one and go to jhook and type org, so it will take a couple of seconds to reflect those DNS changes. And here you can see it has gone. All right, so the next thing which we will do, we will create a geolocation based routing. So click on create record over here, and here we have seen the simple routing, we have seen the weighted routing. Now we'll select on geolocation routing. So select that one, click on next. Again, we'll go with the jhook.org, which is my main domain, and here we will choose the A record because we want to create a record. But here define the geolocation record. We need to create those record based on the country. So select that one, choose the endpoint. So I'm just going to choose application load balancer. I think it's this one. That's correct. Reason, I'm just going to choose EU Frankfurt. Load balancer. So I'm just going to choose first load balancer, which is test load balancer. That's done. And here I need to define the location. So I'm just going to serve the request coming from a Sweden for this particular load balancer. So here I'm just going to choose Sweden. And then I'll just put the record identifier. So here I will put a record for Sweden test LB and then define record. That's been done. Then I'm just going to add one more, and here I will just choose the endpoint as application load balancer, and reason, I'm just going to use Euro Frankfurt. And here load balancer. Here now I'm just going to choose the another load balancer, which is a test VPC from test VPC2. Select that one, and here in the location I will type Finland because I just wanted to have the request only served from Finland from this particular load balancer. All right, so here I will choose the record ID, record for Finland, test LB test VPC2. Define record. All right, so here we can verify once more. So here test VPC2 load balancer from Finland, and the first one is from Sweden. Okay, so both of them are ready. Click on it, click on create records. And here you can see our geolocation based A records has been added to our Route 53. And again, click on view status, and here it is showing the pending state. So it will take a couple of minutes to get it active. Meanwhile, I'll show you my VPN setup so that we can configure the VPN, and then we will be able to test this feature actually. So for that, I'll just open a NordVPN, which I have been using for my personal use. So here is my NordVPN, and I will just choose the region. So click on quick connect, and let's test. It's already connected to Sweden. Here you can see if font is too small, but here you will see connected to Stockholm. So now I'm connected from a Stockholm, and if I take a look onto the diagram once again, so this is my old load balancer from Sweden. So it should point to the IP address of a 12 series because that's the first VPC we have created, and inside that VPC we have assigned the range of 12 IP addresses. So I should get the only EC2 instance from a 12 IP address, and only those should be visible onto my browser. So let's go back to my browser and check the status. So it's in sync, and yeah, I can see it's in sync. Go to the new tab, and here I will just refresh this page over here, and here you can see it is only serving the request from 12, and that belongs to my test VPC, and which is only applicable for my request coming from a Sweden. So if I refresh this one, so here you can see the IP address is not changing because I have configured the traffic coming from a Sweden. All right, so that's we have tested. So let's disconnect this one, and I will now connect to Finland. So let's try to search over here, Finland, and select Finland over here. And let's check. Yeah, now I'm connected to Helsinki, which is Finland. And I will try to refresh the same page once again over here. And here you can see the IP address has changed to now 13. So as you can see, our request is getting directed based on the location because of geolocation based routing. So if you take a look onto the diagram, so here, this is the geolocation based routing which is working. So this is how you define. So if you take a look onto the A records once again, so here you can see we have a 2 A records and one for Sweden and one for Finland. And based on these location, now we are getting redirect. So this is how we configure our geolocation routing in our Route 53. Now let's talk about the last routing, which is like a failover routing. And as the name suggests, so it will work when something fails onto the one A record side. So here I'm taking the same example where we are having a multiple load balancer, which is working inside my AWS account. So there is a one load balancer which is serving, and there is another load balancer which is serving from another EC2 instance. So here you can see this is the request flow. But now what will happen in case of failure? So what we will do, so let's assume that our first load balancer, which is present inside my test VPC with the IP range of 12, fails. Then what will happen is like it will start serving that request from my another load balancer which is present inside my test VPC 2, which starts from the IP range 13. So in that case, we will define primary and the secondary A records inside our Route 53. So in case if primary fails, then we still have a secondary A record to serve the traffic. So that's the purpose of our failure routing. So for that, what we will do, again, we will go back to our AWS console, and now I'm just going to delete this geolocation based A record because we have already seen that demo. So I'm just going to click on delete records, click on delete. And I'm just going to close this one, and here we can see our default hosted zone. So now we need to click on create record. And now we have seen simple weighted geolocation. Let's check the failover routing. Click on next. And here I will just go with the main domain. A records, that's fine. Click define failover records. So click on it. Choose the endpoint. So here I'm just going to choose the application load balancer. Reason, so I'm just going to choose EU, Frankfurt. Load balancer, so here I'm just going to choose first load balancer, and here I'm just going to define as primary because that's the first load balancer which is in the range of IP address 12 inside my test VPC. Alright, so here I just need to define the record type ID. So here I will choose like a primary A record. Click on define failover record, and then add one more define failover record for secondary. So here I'm just going to choose application load balancer. Reason, I'm just going to choose EU Frankfurt. Load balancer, here I'm just going to choose test VPC2 from the test VPC IP range 13. Choose the type as a secondary. Yes, that's correct. And I'm just going to choose the record ID. So here I'll just choose a record. I'll just put secondary first of all, secondary A record, and then click on define failure record, and then select both of it and click on create records. And here you can see our both the A records has been created, and one is primary is pointing to the test LB with the IP range of 12, and this is pointing to the test LB from a test VPC2 with the IP range of 13. Check the status over here, and here you can see it's still in pending. So let's wait for a couple of minutes and I'll be back once it's in sync. Alright, so now both, not both, but at least our hosted zone A records are in sync now and both are active. So let's go back to our diagram and take a look. So now we are simulating the scenario where we want to fail the load balancer from a test VPC from IP range 12. So this primary route, we want to fail it. So what we will do, we will just go back to our home page, go to your EC2 instance over here, go to EC2 instances, and here We are just gonna change the state of this instance, which is test EC2 instance, which is running inside my test VPC with the IP range of 12. So what I'll do, I'll just go to instance state, and here I will just put stop instance and click on stop. So it's stopping that particular instance at the moment. So here you can see it says stopping. And if you take a look over here, so here we have done the stopping of that particular instance, which means our primary, this primary route is down. And now all the requests should be served from my secondary routes. So what we will do, we'll just go back to our browser, and it might take some time to propagate all these changes. So you need to be a little patient, because you might still be having some requests served from our old instance because it's still getting stopped. Okay. So here, just refresh this page. Here you can see the service is temporarily down. It shows that message, but it will take a couple of minutes to come into picture, and it will start serving from our secondary A record type. So I'll be back and we'll refresh this page once again. Alright, so I have waited for a couple of minutes, and let's try to refresh this page once again, and now it should point to the IP address of EC2 instance, which is 13. So let's refresh this page over here, and here you can see it is pointing to the 13. And go to EC2 dashboard once again and refresh this one also once more, and here you can see that's only one instance running. Click on it, and here you can see the IP address, that is 13.0.1.25. This is the IP address, and the same which you can see over here also from our domain name. So this is how you will configure the failover routing into our Route 53. So with that, we conclude our session on a Route 53, and I hope this comprehensive course on Route 53 will help you to understand Route 53 in a much better way. So see you into the next session of our DevOps and AWS session, and also please consider subscribing to the membership program which I have just launched in the previous month. So where I also share more in-depth knowledge sessions which is close to our industry standard. So see you into the next session of our DevOps and AWS. Till then, take care and bye-bye.